This is the packet I gave him yesterday. Also, if you need a new periodic table or solubility chart, they are up there. And then you better make sure you get some notes on them. So at the end of the hour today, Farhan, you're going to want to take a picture of this one so that you can put all the notes onto that one that you just got that are on here. All lefty. Well, you are for one, but there are many that I have. Do you have time for me to give you the whole list, or do you just want the shortened version?
No, I don't have time at all.
Okay, good, because I didn't really want to talk to you anyway. So, all right, Jennifer, Lizeth, where are you? There you are. Okay, Mitzi, gotcha. Jasmine, Avan, Olivia, Leaf. Leaf leaves my class for one day and then comes back. I'm very confused. Move your head. Thank you. Noeva, Aiden. I'm what?
What?
Nothing. You obviously said something. Hang on. You gonna pass it?
Yeah.
Okay, who wrote it?
Miss Kong.
Okay, because it's not on there, so.
Oh, it's gonna come up, hopefully.
Okay.
I messed up my date of birth.
Rocio. Nope. So I got 20, 23, 4, 5, 6, 7, 8, 9, 10, 11. All right, ladies and gentlemen, again, yesterday we started talking about the mole. Yesterday we reviewed naming compounds, both binary ionic and ternary ionic, and about 80% of the compounds we will deal with are either binary ionic or ternary ionic. We will also deal with some acids occasionally, probably about maybe 10% of the time, and then we'll also deal with covalent. Today we're going to review acids, and then tomorrow we'll review covalent compounds. Now, again, I gave you the packet of worksheets for the unit, ladies and gentlemen. Okay? Today we're going to show you how to calculate formula mass, and we may get into molar conversions. We'll see where we're at. But again, if you look at this packet, ladies and gentlemen, you should be able to write formulas for all of the names that are in this packet, ladies and gentlemen. These are the ones that we reviewed yesterday. So looking at them, all of these that are in here, you should be able to write names for. If not, you need to come see me and get some more help. Okay? You need to come see me and get some more help. Again, I'm here before school every day, except for Friday mornings. Okay? I'm here after school every day, Friday only till 3:15. And then I'm here during home base. You can come and see me then. Okay? You are sophomores, juniors, and I don't know, there might be even a senior in here or so, ladies and gentlemen, taking a college prep class. You need to act that way, which means if you need help on something, you need to come and see me. Okay? One of the biggest things that causes students problems is when they start to get behind, they just are like, well, I'll get caught up later. No, you won't. Okay? No, you won't. Okay? And this class builds off a lot of what we did in the first half of this class. And for some of you, that has been a while. I understand that. Okay? That is why I'm here to help you if you need it. All right? So, ladies and gentlemen, we are going to begin today by looking at naming some acids. There are two kinds of acids, ladies and gentlemen. There is a binary acid and there is a ternary. Binary and ternary mean the same thing, whether you are talking about acids or whether you are talking about ionic compounds. Binary means there are only two elements in the compound. Ternary means that there are three or more. Now, what element has to be in every acid? What? Hydrogen. Every acid that we will give you in this class will begin with the element hydrogen, whether it is binary or whether it is ternary. Binary, we kind of see that because the name begins with hydro. So binary acids always begin with the name hydro and always contain only two elements. And one of those two elements happens to be hydrogen. So really all we need is the other element that is in there, ladies and gentlemen. Okay? So let's do a little bit of writing a binary acid here, ladies and gentlemen. All right. All right. So, ladies and gentlemen, for hydronitric acid, it begins with hydrogen. Hydrogen is always a +1, ladies and gentlemen. That means that we are still going to have to do our crisscross method like we did with the binary ionic compounds. But here's the good news. Because hydrogen is a +1, you will never have to worry about reducing acids. Why? This +1 is always going to end up with what the acid is with. So because that's going to be a 1, you never have to worry about reducing your subscripts at the end because 1 will always be part of it. Okay? Now, unfortunately, what hydrogen is with will have a charge with it. And its charge might be -1, -2, -3, -4. We still need to balance off the compound like we did yesterday. So hydronitric has hydrogen in it, and nitric would mean what element? Nitrogen. Remember, there's only two elements here. So nitric comes from nitrogen. Hydrochloric acid comes from chlorine. Hydrobromic acid comes from bromine. Okay? So again, all binary acids begin with hydro and end with ic acid. The formulas all begin with hydrogen. So now we're going to put hydrogen with nitrogen. Now, according to the periodic table, nitrogen has what charge? -3.
Wouldn't it be nitrate?
No. You're getting ternary and binary confused. We're going to get to that in a minute, Cynthia. This is a binary, meaning there are only two different elements. So there are no polyatomics involved yet. Okay? So we are going to take and we are going to do the crisscross method still. This one's going to end up by the nitrogen. I'm not going to put anything by it. This 3 ends up by the hydrogen. So our formula is H3N. Now what else do we have to put in because it's an acid? An IE.
Oh, wait, never mind.
Okay? So hydrogen, 3, nitrogen, AQ. Acids are always aqueous. The definition of an acid is any compound that increases the hydrogen ion concentration in water. So these have to be in water. So that is the way we write the formula for a binary acid. Questions? And we know it's binary because of beginning with that term hydro. Hydro means it is binary. Okay? Now you'll notice nitric acid does not begin with hydro. That is because it is a ternary acid, which means it has 3 or more elements in it. And the only way you can do this is if you have a polyatomic involved. Polyatomics are on the back side of your periodic table. So nitric acid, find me the polyatomic that is close to nitric on the back of your periodic table. What? Nitrate. Nitrate is NO3. Okay? Now, the rule is an ic acid comes from an 8 polyatomic. So because this is an ic acid, it came from a polyatomic that ended in ATE. Anybody remember what the other ending on a ternary acid could be? OUS. And an OUS acid comes from an ITE polyatomic. Okay? It comes from an ITE polyatomic. So, nitric comes from nitrate. Nitrate has a charge of -1. What element do we still put this with? We still put it with hydrogen. All of our acids are going to begin with hydrogen. So now we got a +1 and we got a -1. You can do the crisscross method, but those just do what? Those just cancel out. So in the end, we end up with HNO3. And again, remember, has to be aqueous, has to be AQ. Questions? Bless you. Nitrous acid would come from NO2, nitrite. Nitrite still has a charge of -1. We would still put it with hydrogen, which has a charge of +1. And again, the +1 and -1 would cancel each other out. So HNO2 aqueous. That would be our formula for it. Okay? Questions? By the way, I don't think I give you any, but we could go to hyponitrous acid, meaning we would lose 2 oxygens and be down to NO, same charge, still with hydrogen, it would just be HNO, aqueous. And you could have pernitric acid. Per means we have gained 1 oxygen to make it NO4, but it would still be HNO4 and aqueous. Questions? Okay, there you go. Do them. You have questions? Call me over. First thing, figure out if it's a binary or a ternary. Binary are easy, only 2 elements.
Hydrogen always goes first, right?
Hydrogen always goes first because in this case it's acting like a metal would in an ionic compound. And it always goes first, yes. Now, are there some strange acids that don't have hydrogen first? Yes, but none that we will give you.
To combine the H's or no?
No, do not combine the H's there. Okay? That would make it, yeah, we don't combine the H's there. So even like this, if it were with other oxygens or carbons, don't combine it because we want that to stand out as a group. Okay. Good question.
Interesting.
But other than that, it's okay. Yes, all of them start with H, yes. Every one that I will give you starts with hydrogen.
Wait, so how does this work with the ITE and ATE?
Okay,
So it only gives one oxygen.
so for example, carbonate, CO3, okay? It becomes carbonic acid. Okay, but if you had percarbonic acid, it would be CO4 because the carbonate is CO4. Okay,
So if it's if it ends in ATE,
anytime it ends in ATE, it becomes an ic acid. Even if it has the per, it will still become an ic acid. Anytime it ends in IT, either one, anytime it ends in IT, it will become an OUS acid. The question is, did it lose one oxygen and it just is like carbonous acid, or did it lose two and it is hypocarbonous acid? So this naming system can translate into acid because anything that could end in an ITE would become an OUS acid. Anything that could end in an ATE would become an ic acid.
so do I only apply for acids?
No, they apply for a ternary compound as well. You can have sodium carbonate, okay, Na with this, or you could have sodium carbonate. It could have lost one oxygen and be a CO2 instead of a CO3.
Oh my gosh, get off your phone, sorry.
I'm not on my phone, that's a timer because we're gonna ask it. I'm gonna need more time.
Like a minute or two.
Okay, that's fine, maybe a minute or so. That's fine.
Like 1 minute.
Be careful what you say about me, it's my gosh too.
Nothing I'm doing.
Okay, go ahead.
It was like the middle of the flower. You know, like the middle part of the flowers and it's
That's true, right?
So what you're saying is I'm super bright. That's what I got out of that whole conversation. Mr. Brain, you are super bright. Thank you, Cynthia. Do you have a question? Cynthia, wait, let me look at your list.
Well, you
Your last one was not right.
It was
That's an OUS acid, not an IT, not an ic acid. That's what we were just talking about.
You said that, right? Hydro goes with everything?
No, hydro only goes with binary.
Like
There are some of those
the
names.
H.
Hydrogen goes in every formula, but hydro in the name means that it's binary. Yes.
Wait, I don't get it.
And what's wrong with that is that it's an OUS acid, so it came from an ITE polyatomic. It did not come from bromate. So what's the difference in formula between bromate and bromate?
Yeah, then we got all these.
In ITE, you lose one oxygen instead of CR4. Yes, that's it. This one. Okay, but you read the wrong polyatomic. You read acid instead of No, that's fine. So your thinking is correct.
Because there's two. So there's two. Merge. I did not do that.
How is it? Shouldn't it be one of these?
3 bucks.
It should be, but remember, chromos would be from chromate. If that's an ATE ending, that would make it ic acid. To be an OUS acid, it has to come from what polyatomic?
Why did it not?
No.
I don't have the memories in my head.
ITE.
He's gonna fail.
Instead of chromate, CrO4, it comes from chromite, CrO3. Okay, so everything you did was correct, you just had one too many acids. Sir? No, not too bad.
Didn't break it.
What's that?
Didn't break it.
This one, you need the polyatomic, not just sulfur, sulfate on the back. That one's good, that one's good, that one's good, and we haven't gotten that one yet.
All right, ladies and gentlemen, again, when you do these, the first thing that I would try to identify in an acid, is it binary or is it ternary? Because once you determine if it is binary or ternary, ladies and gentlemen, it becomes much easier for you to do the naming process. Binary, 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 meaning there will only be 2 elements in each of those 3. When it is ternary, ladies and gentlemen, that means there will be a polyatomic involved. So all of these start out with hydrogen, every single one of them. The question is, what is the hydrogen with? Hydrobromic, hydrogen is with bromine. Bromine is a -1, hydrogen is a +1. Therefore, your formula is HBr, and it is aqueous. Do not forget the aqueous. For hydrosulfuric, I'm sorry, I said hydrosulfuric, but this is just sulfuric. Hydrogen is with the polyatomic ion sulfate. ATE ending gives us an ic acid. So sulfate is SO4. Charge is a -2. When we balance these off with the crisscross method, we get H2SO4, and it is aqueous. Questions? Acetic acid, hydrogen is a +1 again. Acetate is C2H3O2, and it is a -1. Now, someone asked, can we combine the hydrogens? No, do not do that. That would be changing the polyatomic. We never change the polyatomic. Even though there is hydrogen here, we put it out in front. So H, C2H3O2, and it is aqueous. Questions? Hydrocarbonic means hydrogen and one other element. For carbonic, that means carbon, which is a -4. Formula H4CAQ. Hydrophosphoric means hydrogen +1, phosphorus -3, H3P, aqueous. Chromous acid, hydrogen +1, but chromous comes from an ITE polyatomic. You will not find ITE polyatomics on the back of your sheet. They are all ending in ATE. You have to understand that ITE means that it has lost 1 oxygen. So you will not find chromite on the back. You will find chromate. Chromate is CrO4. So to be chromite, it is CrO3. Charge is a -2. Thank you. So we have H2CrO3 aqueous. Questions? Now, again, the nice part about hydrogen being in here, ladies and gentlemen, is you will never put any of these in parentheses. Never. Okay? Because the only number that would go by these is a 1. No need to ever put these in parentheses, unlike when they are in a ternary ionic compound. Sometimes they're with something that has a charge other than 1. So there are times where you will have to put a number by them. We would have to put them in parentheses. You may, however, have to change the number of hydrogens, though, because these do have different negative charges. Questions? All right, ladies and gentlemen, open up your EISNs, ladies and gentlemen, and get to slide number 6. All right. So this is where we left off yesterday, ladies and gentlemen. Molar mass is the mass of 1 mole of a substance. The mole takes something that is way too small for us to measure, an individual atom, and moves it up into something that we can measure. You and I can measure grams on a balance in the back of the science room. We cannot measure atoms. They are just too small. So the concept, the idea of the mole is to take something that is way too small and move it up into something that is useful or measurable to us. So right here, ladies and gentlemen, I have a mole of zinc. And how do I know I have a mole of zinc? KP, what's the mass of zinc on the periodic table? Number 29. Or, sorry, number 30. My bad.
65.39.
So when I have 65.39 grams of zinc in a sample, I have 1 mole of it. And that is what I have here. Here, I have 1 mole of copper. Why? Because I have 63.55 grams of copper here. Are these the same size? No. Why not? An atom of zinc is bigger than an atom of copper. Okay? You would not expect a bowling ball and a golf ball to be the same mass. But if you have a dozen bowling balls and you have a dozen golf balls, you have the same amount of each. Now, how much space are they going to take up? Bowling balls a lot more. Golf balls a lot less. But you're going to have the same amount of each, and that's what I have here. I have the same amount of each of these. I have 6.02 times 10 to the 23rd atoms of each of these in my hand. Here's a mole of lead. How do I know? Because I put 207.2 grams of lead in this container. Therefore, there are 6.02 times 10 to the 23rd atoms of lead in here. Why atoms? That's what makes up the element lead. Here is 1 mole of iron. What's the mass in here? 26 on your periodic table. Nope, the top one. $55.85. Bigger or smaller atom than copper? Smaller. Smaller. Fewer protons in the nucleus, fewer neutrons. It's a smaller atom. Okay? But again, you don't expect a paper clip and a donut to have the exact same mass. But if you got a dozen of each, you got the same amount of each. That's what I have here, the same amount of each of these. Not the same mass, the same amount, the same number of each. And here's a mole of magnesium, 24.31 grams. Now, I will tell you, ladies and gentlemen, your periodic table and that periodic table, the masses may be slightly different. We are not going to argue over hundreds or thousands of grams. Okay? We're not going to do that. So sometimes you'll hear me talk about oxygen being 15.9994. Why? Because the periodic table that I used years ago, that was the mass on it. The one that I gave you this time has a mass of 16.0. We're not going to argue over 1,000th of a gram. Okay? Now, if you have something that is an element, the mass on the periodic table is in AMUs. Once we take a mole of it, that moves our masses out of AMUs and into grams. So 1 atom of zinc has a mass of 65.39 AMUs. We could never measure that. Never. Way too small. But we can measure 1 mole of zinc, and that is 65.39 grams. That we could do on a balance. We could never measure 1 atom of copper because it's too small, 63.55 AMUs. But when we take a mole of it, now we're measuring in grams. Something that we can do in our lab. Okay? By the way, 2 moles of this, what would its mass be? Anyone? Anyone?
127 point something.
Very good. Very close. 127.1. 127.1. We would double that mass. What if we only had a half a mole? What would we do to the mass? Yeah. So guess what? Everything is proportional. So we don't always have to work with a full mole of something. We could work with a half a mole, a quarter mole. We could work with 0.87 moles. And that's what we will be doing. Now, these are elements, ladies and gentlemen. Okay? This tells us there's 6.02 times 10 to the 23rd atoms of all of these. This, and this are compounds. They are compounds. Some of them are ionic, some of them are covalent. Meaning these are not made up of atoms. That's not the smallest unit here. The smallest unit of table salt, NaCl, is a formula unit. 1 formula unit, 1 NaCl. Now, what's the mass of Na on the periodic table? 22.98. What's the mass of chlorine? 35.45. Since this is made up of sodium and chlorine atoms bonded together, guess what we do to those 2 masses? We add them together. We add them together. Okay? To get 58.43 grams in here, which means I have 1 mole. Which means I have 6.02 times 10 to the 23rd FUs in here. Formula units. Why formula unit? Because I cannot call an ionic compound a molecule. However, in here, I have water, H2O. That is a molecule. The mass of hydrogens on the periodic table, 1.01. The mass of oxygens on the periodic table.
16.
But we got to be careful because how many hydrogens are in here? 2. So we have to double that 1.01. 2.02. Now add the 16 for the oxygen, which means if I have 1 mole in here, how many grams? 16 plus 2.02. Don't you dare pull out a calculator.
18.02.
18.02 grams. When I have 18.02 grams of water, I have 1 mole of it. So guess what? If I took this salt and this water, I could match up one formula unit of salt with 1 molecule of water, and they would all be matched up. Each one would have a partner because they're the same number of each in here. Same number of each in here. Here's glycerin. Okay? Glycerin has a formula of C3H8O3. Quiet! So, 3 carbons. Nobody listens. Nobody. 3 carbons, 12.01, 36.03. 8 hydrogens, 8.08. 3 oxygens times 16, 48. Add all those together, you get 92.1 grams. So when I have 92.1 grams of glycerin in here, I have 1 mole of it. 1 mole, same amount as each of these. And I can call this a molecule because this is a covalent compound. I can't call this a molecule. Why?
It's only one element.
And it's a what? What are the pieces that make this up? Atoms. Atoms. Sugar. Stuff you put in coffee, iced tea.
I think we know what sugar is.
What?
I think we know what sugar is. Yeah.
Did you know there's different kinds of sugars?
Yes.
Oh, okay. What kinds are there?
There's different kinds.
Like?
Like different kinds.
Like?
Like brown sugar.
Oh, brown sugar.
Well, yeah, you go around. This is sugar we use for coffee, whatever. Like we all know that.
Oh, okay.
Powdered
Okay.
sugar.
Yeah, powdered sugar. See?
Oh, good. Good. Good.
You have to watch your sugar intake, right?
Oh, always. Always. I look
No,
at
you
every
specifically, yeah.
thing of food that I eat, I watch it. Yes. Okay. Formula C12H22O11. 342.3 grams in here. Why? To get 1 mole. By the way, which is bigger? A particle, let me rephrase that, a formula unit of salt or a molecule of sugar? Much bigger, correct? Much bigger. We don't expect these things to be the same size. They're made up of different atoms, different amounts of them. They will be different. Questions, ladies and gentlemen? Good. So, for us to find a molar mass, ladies and gentlemen, we need a couple of things. Okay? One, we need the formula. What is in the formula? AlCl3, aluminum chloride. AlCl3, 1 aluminum, 3 chlorines, correct? Where do I get this 1 and this 3 from? Where did I get the 1 and the 3 from here?
The chart.
No, not the chart.
Aluminum, 3 oxygen.
From the formula here. This says 1 aluminum and 3 chlorine. So the formula gives you how many? Now, where do I find how much mass they have? On the periodic table. Now I figure out what the mass is. Every aluminum has a mass of 26.89, according to the periodic table. Every chlorine, 35.45, according to the periodic table. But I have got 3 chlorines. So what do I need to do to this? I need to multiply it by 3. So for a formula mass, you take the mass of each component times the number of each component. And then you add it to the next part of your formula. So 1 times 26.98 for aluminum plus 3 times 35.43 for the chlorines means 133.33 grams will give me 1 mole of aluminum chloride. That's formula mass, ladies and gentlemen.
Wait, so the formula masses, or like the mass is the mole? Like 1 mole? Like what's the difference between the two?
Well, what's the difference between 4 quarters and a dollar bill?
Nothing. So it's
Nothing?
the same-
Really?
Well, more
Well-
value.
No, same value.
Well, there's more of them, but
Okay.
same value.
It's a different unit and a different number, correct?
Yeah.
But they are equivalent to each other, meaning you have the same amount of money, right? Well, when you say you have 133.33 grams of aluminum chloride, you could also say that you have 1 mole of it. These are equal to each other.
So the mass is the same as like 1 mole.
When you have the formula mass of a substance, you have 1 mole of it. Yes.
Okay.
If that's the way you wish to think of it, yes. Okay? That's what it means. Okay? Questions? Okay. So if we have something like C12H22O11, or what again, Cynthia? What is that? What is that? Oh, okay. Thanks for helping her out. Next time, leave her hanging on her own. Okay? 12 carbons, 22 hydrogens, 11 oxygens. Masses off of the periodic table, 12.01 for carbon, 1.01 for hydrogen, 16.04 oxygen. Mass of each component times the number of each. 12 times 12.01 plus 22 times 1.01 plus 11 times 16. 342.34 grams, ladies and gentlemen. And when you have 342.34 grams of sugar, you have 1 mole of it.
Can you do subscripts again?
Subscripts, control, comma on your keyboard.
So basically, we're kind of just doing the math to what the formula's telling us.
Correct. Correct. But guess what? If you write a wrong formula,
You get it wrong.
you get a wrong mass.
That's insane.
I know, it's insane. It's like when you're talking about something, if you're not talking about the right thing, you're not going to get the right answer. Wow, who knew? Who knew? Questions?
No, that
Wait,
also
what are
didn't
you
work.
doing?
I switched the thing because I asked if there were questions. Nobody said they had any, so I
It
moved
took
on.
2 seconds to answer, so.
You guys haven't asked me a question all trimester.
It's because
I just asked one like 5 minutes ago.
Do you want us to be done?
All right,
Or would you guys
all
like to
right,
mark that?
you got that one right. What, KP?
We just know our stuff like that.
Okay, so I thought I could move on.
No, but like there's
No, but like what?
there's a difference between filling in and like knowing what you're doing.
Asking, what are you talking about?
He
We're,
doesn't
we're
know.
talking about, we haven't finished typing it out. You're talking
He's
about
old, the dementia
everybody
sitting him.
participating or whatever.
I guess I didn't realize you were that slow a typer, Cynthia. That's
No,
my
that's-
fault. I'll give you much more time to type. Has everyone typed their things in? Can we move on?
Yes.
The subscript isn't working for me. Like I'm pressing C, TRL, and comma. It's just
Okay, but then do you type afterwards? Because that puts it into the mode to then type. And then hit that again to take it out of that mode. Or you can highlight what you
Oh
typed
my gosh.
and then hit the control and that comma, and it will then put it into a subscript.
thank you.
Sorry. Good. Questions? Okay, take out your packet, ladies and gentlemen. Let's look at the second one. Sodium sulfate. All right. Sodium sulfate. I need a formula. NaSO. That is definitely not even close to being correct.
Isn't that Na2? That's the four. Yeah. Something like that.
Like what's your burn rates mean?
Just natural.
Na4SO.
Na2SO4. Questions?
No.
Do we understand why?
Yeah.
Do we?
Okay, anyone other than KP want to speak up?
Can we do this with acids too?
You could do this with any compound. This is the way of finding the formula mass for any formula. Now, our formulas might be ionic, might be covalent, might be acids. Any formula we would do the same thing to. Great point. Great point. So, how many sodiums? Okay, so we got 2 NAs. How many sulfurs? 1. How many oxygens? 4. So down here, we're going to put 2 times what's the mass of each sodium?
Yeah, what she said.
Then we're going to take 1 times the mass of sulfur, 32.06. Then we're going to take 4 times the mass of oxygen, 16. So when we add these all up, ladies and gentlemen, we will get the grams in 1 mole of sodium sulfate. So now would be a good time for you to take out those fancy dancy calculators that you have, or come over here and grab one of mine and get some calculating done. And by the way, ladies and gentlemen, as my classes learned last trimester in the second half, the students who sat around and never did any calculations and thought, oh, I'll wait for Alexis or I'll wait for Cynthia or someone else to do it, that is fine. But guess what? When they got on the test and they didn't know how their calculator worked, and you're sitting there going, well, what idiot wouldn't know how a calculator works? You would be amazed How many people got wrong answers because they didn't put it into their calculator, right? Because they never practiced it. So 2 times 22.99 would be 45.98 plus 32.06 plus 64.
Wait, can we type it? Can we type it like all together?
You can do it all together, and that's the way I would do it.
It won't make a difference.
This times this plus this times this plus this times this. It's going to do the multiplication first, and then it's going to add them together. Very good. Thinking about orders of operation. That's a lot better than my classes did last trimester. Good job, Cynthia. So, what do we get for a total?
142.04.
142.04. Oh my God, we even got agreement on 2 people doing the calculations. That's amazing. Grams equal to 1 mole of Na2SO4. So when you have that many grams, it is equal to 1 mole of Na2SO4. Questions?
So 142.04 is the mole of Na2SO4.
Run that by me again, I'm sorry.
So 142.0 is the mole of the formula of the whatever.
Is when you have 1 mole of Na2SO4. Now, difficult math here, ladies and gentlemen. Stay with me. Stay with me. Are you ready? Are you ready? Are you ready?
No.
Good.
1.
One.
Any questions there? Good.
What is that? No, I passed, like elementary school math. So.
Okay, you got this one then. Why?
Because it's the same.
Anytime you have 2 quantities that are equal over one another, what do you get? 1. What? You sure?
1 mole of Na2SO4. Yeah, 1. Itself 1.
So does it matter which one I put on top and which one I put on the bottom? As long as they are what?
Equivalent.
As long as they are equal. Long as they are equal. Good, because that's going to lead us into how to do conversions in just a minute, ladies and gentlemen. Okay? Going to lead us into how to do conversions. Questions? Can I leave what?
Just leave it with,
Leave
just
class.
end, yeah, just end the unit.
Oh, you want to end the unit on this?
Yep.
Heck no. My gosh, that's not even a possibility. Don't be ridiculous.
Don't be ridiculous.
Thank you. Yep.
Always copying you.
And you were doing a very nice job, I want to say. Very nice job.
Yeah, my brand impersonation is really good.
It is. It is. It's one of the top 3 that I've heard today.
Okay, is that how you want us to write it? Is that why there's 2 boxes?
No, the 2 boxes was if there were 4 different elements. So I made these so that no matter how many elements, they should fit. All right, ammonium chromate. I need a formula.
NH4 in parentheses and then 2 and then CrO4.
Okay, did I mention that I wasn't quite ready yet to write? But okay, go ahead again. Sorry.
Well,
Be ready then.
parentheses NH4 parentheses 2.
Whoa, what do you mean parentheses 2?
Like,
Like
the end of
at end of
Okay,
parentheses.
you can just say parentheses around the NH4 or whatever. Okay,
And then
2.
CrO4.
Good. Good. Very good. Now, remember when I think it was Sophia asked me, do we have to put the hydrogen in front of the C2H3O2? You remember that? Yes, you would have to put hydrogen in front of the acetate to make acetic acid. But down here, I don't care where the elements come from. In other words, if they're in one spot and another, you can add them together then, okay? For formula mass, all I want is the total mass of everything involved. So how many nitrogens? 2. How many hydrogens? 8. How many chromiums? 1. How many oxygens? 4. This is why I had the 4 boxes there, Cynthia. And then we'll do the total down below. So 2 times 14.01. 8 times 1.01. 1 times, sorry, chromium I don't have memorized. Thank you very much. And 4 times 16.
So that's 0.94 or 99 for
99. So give me an answer, ladies and gentlemen.
give me a minute.
Okay.
Wait, so let's say if we just had NH4, should we just do like
1 N plus 4 H's. I'm sorry, I cut you off, Cynthia. Go ahead.
would it work if you just did like because it says NH, so you would just do 4 nitrogens plus 4 hydrogens. Do you know what I'm
No, I'm sorry, I'm really not understanding.
So you have NH4, right?
Yeah.
So since you have 4 of like that thing combined, like NH combined, could you just do like 4 H's and 4 N's and just combine them together to get
No, because here's the thing that you're missing. This 4 only goes with that H.
Oh, okay.
This 2 then multiplies the
Yeah,
N.
but what if we didn't have the 2?
Then you could do just 1 nitrogen plus 4 hydrogens.
Oh,
Okay? Just 1 nitrogen plus 4 hydrogens. All right, you had your minute. What do we got?
152.09.
Anybody else? 152.09?
So like, do we just ignore the charges?
Well, no. Your charges you used to write this formula.
What about the subscripts? Well, like, I mean, when we're putting them together and adding.
In here?
Yeah,
Well, here's the thing. Your charges got you this formula.
yeah,
The -2 here is why you have a 2 here.
yeah.
The +1 is why you have nothing there. So once you've written a good formula, which you have to do by charges, then all you need to do is this.
Yeah, but like, I'll ask you. Later.
There's only one way to write that formula.
I
Thi-
know that, but I'm talking about like, how are you getting the like 1 CR and like 4, like what number is
Okay.
off that?
Here's how. This is a +1. CrO4, which is chromate on the back of your sheet, is a -2. So that 2 goes down by the NH4. The 1 comes down by the CrO4. That's what I mean by you have to write a good formula first. This is a good formula. Your charges are balanced. The total charge on this compound is 0. Now, when you do this, you're going to get the correct formula mass. Okay?
So, for like the CR, for instance, like it's only 1 because the 4 isn't directly next to it.
Correct.
Okay, that makes sense.
And
I'm
you
good.
Correct.
parentheses.
I'm good now.
Correct. Now remember, NH4 in parentheses 2, this 2 multiplies the nitrogen and the hydrogen. So that's why we get 2 nitrogens and we get 8 hydrogens.
Okay, that's what I was asking.
And like you were just saying, the CrO4, this 4 only goes with the oxygen because it's next to it. There's nothing by the Cr, which means that's one of them. Okay? So if it goes in parentheses, what is outside the parentheses multiplies everything inside.
Okay, I got it.
Since there's no number by the Cr, that means there's only one of them. Since there's a 4 by the oxygen, there are 4 of them, but that 4 only goes to the oxygen. Questions? Excellent, excellent, excellent. So now, ladies and gentlemen, how do we use this? Well, we use this to convert with the mole. Okay? We use this to convert with the mole. Now, yesterday I had you write on the top of your sheet the conversions with the mole. You can go from particles, mass, or volume into moles. And you can go from moles into particles, mass, or volume. Each one of those is a step. You can go from particles to grams, but that's 2 steps. You can go from volume to particles, but that's 2 steps. You could go from mass to volume, but that's 2 steps. But the good news is the steps, we're always going to do them the same way, and we are always going to let our units help set up the problem by canceling out. So, for example, ladies and gentlemen, calculate the mass of 6.89 moles of antimony. Now, what do I need to know first thing to do this problem? And more specifically, I need to know if antimony is a compound or an element. Is antimony a compound or an element? Element. What's its symbol?
SB. That's so weird.
Why?
Why is it SB?
Probably from some Latin or some Greek root. Okay? So, SB. So, 1 mole of SB equals how much?
121.76.
0.76 what?
Grams.
Grams. Okay? So 1 mole of antimony is equal to 121.76 grams, correct? Okay, so what am I beginning with here? What did the problem tell me? How much am I starting with? Read the problem.
6.9.
So I'm starting out with 6.89 moles. And I want to get to what eventually? What unit is mass in? Grams. So I want to get from moles to grams. I can use this as the conversion. Now, how do I know what goes where? Well, that I'm going to let my units help me set up. So part of this equation, part of these 2 things that are equal, one part needs to go on top, one part needs to go on the bottom. Which part goes where and why? What? You want moles on top? So 1 mole of SB over 121.76 grams. Correct? No.
No, because the mole on the bottom doesn't want to cancel it out.
Thank you. This doesn't allow the moles to cancel out. That's okay. That's the point. We're going to let our units set up the problem. It's not going to be, well, I really like moles on top here. No. We're going to let our units set up the problem. Okay? So, undo. I want this. So, on the top, we're going to put the 121.76 grams. Why? Because it's the unit we're going into. And on the bottom, we are going to put 1 mole. Why? Because it's the unit that we're in. These now cancel out. Now, mathematically, what do we do to this problem? What?
Oh, you cross multiply.
You don't have to cross multiply here.
They're both on the top.
Take this. By the way, this is not in a fraction, right? But it's considered to be, if you really want to put it in a fraction, what could we put it over? 1. I don't know why, but if you need to do that, please feel free to do that. So I'm going to take this number times the number on top and divide by the number on the bottom. But what's the number on the bottom? So would I ever do that? No, why not?
Because you get the same answer.
Yeah. So if the 1 is on the top, guess what? I'm not going to multiply by 1. I'm just going to divide by the number on the bottom. So as long as one of these is a 1, boom, you don't have to do that part of it. So take this number times this. What are we left with? Well, we're left with grams of antimony. How many?
Antimony an element or like
Antimony is an element. SB on your periodic table, number 51 in your heart.
I got 838.93
What's the unit
grams.
of antimony? Now, there's only one thing that we haven't done yet, ladies and gentlemen. What is it?
simple.
Sig
The 1023.
figs. Sig figs? What? Who said sig figs?
Sig figs.
Sig figs. Oh my gosh. Yes, we got to do sig figs. Oh my gosh. How many sig figs in here? How many sig figs in here?
3.
How many sig figs in here?
3.
I've seen how many different answers I could get. Okay. 3. So how many does our answer have to have?
3.
So how do we round this to 3 sig figs?
Just round the 8 up to a 9.
Okay, so 900 and what?
839.
Oh, I'm sorry, wrong 8. I grabbed the wrong 8. 800 and what?
39.
839.
I hate sig figs.
Why?
I don't know.
There's your answer. 839 grams of antimony.
No, they're not.
Questions?
You just look for the zeros.
They're worse than fractions.
What is a what?
Oh my gosh.
What is
It means about. So that's when you round up. That's when you use the little squiggly lines because it means like a round. So like I put equals 838.93 G's.
In other words, you're complaining about my doing this. That is before I put it into sig figs. And we always need to put a number in sig figs. Why? Because we're in science and precision matters. So we will always put our numbers in sig figs, ladies and gentlemen. Now, you want the good news or the bad news?
That was the bad news.
What was?
Sig figs.
Did you have to put them in sig figs? Yes. You want the good news? 99.9% of the time, your answer will be in 3 sig figs.
Wow.
Because that's the way most problems are written. Most times, there is one measurement that will limit you to 3 sig figs. So if you're an anti-sig fig, if you're a sig fig hater, ladies and gentlemen, make sure all of your answers go into 3 sig figs and you'll maybe lose 1 or 2 points on the test. Give them up if you're not going to learn it, though. Okay? So just put everything in 3 sig figs. Doesn't mean you'll always be right, but probably about 99% of the time you'll be right. Good. Questions? Good. Let's move on. What? Yeah, because we use the mole to convert between moles and mass. Right? Good. Don't worry. You'll only have to do it on your quiz on Friday. Don't panic. You know, that's a great idea. We should have a quiz on Friday, KP. I like that. Yes.
Mr. Quinn, don't even blame this on me.
You called me Mr. Quinn? You called me Mr. Quinn?
You should have seen how many times I did that to him first try. And then I called Mr. Quinn Mr. Brand. It was awful. Now I call you Mr. Quinn.
How a sample of potassium chloride has a mass of 223 grams. How many moles of potassium chloride are present?
Too many.
Nope, that's not a number. Sorry. What? First thing we got to do is what?
Find the mass.
Nope.
We already have that.
Like don't you have to figure out like the normal one? Like
Oh,
one
like
mole
the
and
mass
then
of
you
a
say-
cell.
Okay, but before we can find that mass, what do we need to find?
The formula.
We need to find the formula. You can't find a formula mass without a formula. Potassium chloride, what's the formula? No, potassium is not P. How could you even think about calling it P? Okay, instead of being isn't it, how about we do this? Potassium plus 1, chlorine minus 1. What would be the compound?
No, but like we're trying to memorize the charges, you know, we're trying to get studious.
Okay, good. But then let's say, let's not say, well, is it or is it? No, let's say, okay, let's break it down. Potassium's a +1, chlorine's a -1, KCl is our formula. All right, now what's the mass of potassium?
39.0983.
Let's though, can we, just so that we don't confuse people, can we try to use our pink periodic tables? Only because you're right. When you look up there, KP, you're going to get a slightly different number. So on our pink periodic table, it is 39.1. And again, we're not going to argue over thousands, hundredths of a gram. So understand, your number may be slightly different than mine, but that's okay. So 39.10. What's chlorine? So that gives us 74.55 grams of KCl, which is equal to 1 mole of KCl. Correct? Okay, so we are given a mass and we are trying to go to moles. So we start out with what we're given, 223 grams of KCl. I'm now going to take this and make a conversion factor out of it. But what needs to go where this time? Why? So they cancel out. This time we're putting moles on top. This time we're putting grams on the bottom. Why? Because it's the only way to get grams to cancel out. Okay, somebody tell me how many moles? Should be around 3. 2.99128. Why did you give me so many numbers? How many do I need? 3. So what is this to 3?
10.9.
Moles KCl. By the way, for your final answer on a test, on a quiz, okay, this conversion gets you 2 points. 1 for setting it up correctly, 1 for calculating the formula mass correctly. This answer gets you 2 points. 1 for giving me the correct number, 1 more for sig figs and correct unit. Now you don't need to put the KCl here, but you have to at least put the mole here.
Okay.
So 1, 2, 3, 4, and then I would ask you to tell me what the formula for the substance is. This would be a 5-point problem. Question. Wonderful, wonderful, wonderful. Farhan, before you leave, I would take a picture of this with your phone and I would make sure everything that is copied on there is copied onto your periodic table so that you can do it well. My calculators go back over here, ladies and gentlemen, so you don't accidentally take it with you and then I have to put them away. And then you have to bring your own calculators for tests and for things that we do in here every day. So, questions, comments?